Arrived at the University of Minnesota on September 1st, 1951, and I was coming from Harvard, where I was a PhD candidate, and I'd completed my thesis, but they didn't have a commencement until around March, where the degree was actually awarded. So it's officially a PhD in 1952. But I spent the year of September through June as a DuPont postdoctoral fellow at the University of Minnesota with Professor Walter M. Lauer. And then I became an assistant professor for the following summer and year. And then I was put on the tenure track the year after that. You're on your own, basically.
Okay.
The universities in those days did not have waste management programs.
Mm-hmm.
So it was your responsibility as an instructor and teacher to take care of the problems as they arose. And the attitude of the administration, I think, would be one of, it's not our immediate problem, but we don't want bad publicity or anybody to get hurt. I should change the order of that. No people injured, and no idea that they're not concerned about safety. But the professor pretty much was a person responsible for each experiment, and then you take it from there. A lot of them went down the drain, especially if they were water soluble. Pour it into the ground, which is postponing the problem. Solid waste.
Yeah.
Wastebasket. Well, it was a very gradual process. And there are many years between 1951 and the present. And so things gradually evolved. The university realized that they had to go beyond having the chemistry professors or any other professors dealing with chemicals handle it all on their own.
Okay.
Well, now I'm personally interested in recycling over and above what happens in the chemistry labs.
Mm-hmm.
It is a general philosophy that wherever possible, chemicals should be reusable in some form. It doesn't cause a waste disposal problem. I've had more than rumors about it. I've done it myself. And so I went with a student, and we took a fairly high point down below East River Road, and threw it off the bluff. The potassium, of course, we had it in this jar, and it had some hydrocarbon in it. I don't know what it was. But when it gets dumped into the river and the cap is off, it's going to start tipping and water will get in. And once the water gets in and has contact with the metal, not just with the solvent, it's going to catch fire. And the fire will become very violent. It'll be a detonation because the hydrogen that's produced will burn in air. And so a jet of purple liquid came up out of it. It was a beautiful fountain. The fish are another matter. When the detonation does occur, the fish in the immediate area will be wiped out. And there's nothing you can do about that. Go to a parking lot on a Sunday. First, you got everything in an open pot. Pour it into an open pot with a solvent above it. And then toss a match and get away as fast as possible. So first of all, it'll start to burn. And the hydrocarbon will burn in probably a smoky flame, or not necessarily a blue flame. And Once that is burned up, or before it's all burned up, the metal may catch fire. Now the metal has a very hot flame, and so when the fire spreads to the metal, it'll be a lot brighter fire, a lot brighter flame. But then it'll burn away. Suppose you have an acid chloride, which reacts vigorously with water. And there are a lot of those that we use. One of them is phosphorus oxychloride, POCl3. Take a hood that has a cup sink, turn the water on full blast, and the phosphorus oxychloride, as soon as it hit the water, would turn into hydrochloric acid gas. And so the fumes would come out into the hood and be carried away. And that's a large roar accompanies that. I've done it. I know how it sounds. And you're pouring it. You've got your hands protected with some kind of rubber gloves or something, so that if it splatters, you won't burn yourself. And then hold it. There'll be a shatter shield. You have a shatter shield in front of you, in addition to the shatter shield built into the window of the fume hood. So you work around the inner shatter shield. And just pour it gently enough that it has time to react before it gets very far down the pipe. Probably when a hazardous waste disposal system was developed, so we wouldn't have to do that. We did it of necessity, not by choice. The biggest problem is that when you store glass bottles with paper labels on them in a storage shelf and so on, fumes will develop of the acid, and they will attack the paper label. And so before time, you can't read that label anymore. And when that happens, that becomes a candidate for hazardous waste disposal. You don't want it around. Faye Thompson was my PhD student.
Okay.
Okay.
And she did a great job of running the department